Welcome back to Calculus 1, and today we're going to learn about what is a derivative. So the derivative is the instantaneous rate of change, also known as the slope of the tangent line. So the tangent line intersects the graph at one point. And the picture to the right demonstrates the purple line is a tangent line at the value of the dotted line. So that's just a non-mathematical definition, but we need one. So we have, remember this little formula from Algebra 1. We need to use it in order for it to become dy dx, which is a infinitely small change in y over an infinitely small change in x. So in order to use that, we will introduce the notion of derivative notation. So we can denote either an f prime of x or y prime, or y dot on occasion, which is equivalent to dy dt, but it's more seen in physics. So we have new formula, which is, these are the definitions of derivatives. Small change in y over the small change in x. And similarly here, we have the small change in y and small change in x, which is exactly what the limit is going to get to, closer and closer to that value. So we will use the one on the left when we want to find an expression for the derivative, and the one on the right when you want to find a specific value. So for question 1, find an expression for the derivative of f of x equals x squared. So we want an expression, so we're going to use the first one. So we're just going to copy it down. So f of prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, well, this is our f of x, and we'll just rewrite the limits one more time for proper notation. So f of x plus h is going to be x plus h squared, because all you're doing is you're just plugging the x plus h into the x squared, the minus f of x, and the f of x is just x squared divided by h. So in order to solve this limit, we have to expand the x plus h squared out, and we'll rewrite the limit one more time for the sake of consistency and correct mathematical notation. When that is expanded, you'll get x squared plus 2xh plus h squared minus x squared divided by h. So these two x squareds will cancel out. And when you have the limit as h approaches 0, you have 2x plus h, because these h's cancel out. And when you plug in h as h approaches 0 for this limit right here, you get 2x. And if you remember the product rule, which is going to be in the next video, if you've already been in a lecture, this is exactly what f of x equals x squared implies. So therefore, f prime of x is equal to 2x. Okay. What is the value? What is the value of x equals 4 if f of x equals x squared minus 5x plus 4? Well, we're asked for the value, so you don't have to use the left one that we wrote down for the first problem, but rather the right one. So we can copy that, but instead of c, we'll do f prime of 4, because that's what we're trying to find. So f prime of 4 is equal to the limit as x approaches c, and c we said was 4, of f of x, and f of x is x squared minus 5x plus 4 minus, then f of c, so it's going to be 4 squared minus 5 times 4 is 20 plus 4, so it'll be 16 minus 20, so we negative 4 plus 4 is 0. Then divided by x minus c, which would be c is 4. So we'll just solve this limit. So we have a limit as x approaches 4, so we're going to factor the top, so it'll be x minus 4 and x minus 1 divided by x minus 4. Those two will cancel out, and when you plug in 4 for the x minus 1, you get 3, and that will be our derivative there. And if you really wanted to check, we can use we'll learn this more in depth in the next video, but we can take the power rule and do f of x is equal to 2x squared minus 5, and x is 4, so 2 times 4 is 8, minus 5 is 3. Okay, what is an expression for the derivative of f of x equals 1 over x? So we're switching back to the left form right here because we want an expression. So we will write down the correct mathematical notation, which is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h, and then we'll use the x plus h and we'll plug that into our function value. So it's going to be limit as h approaches 0 of f of x plus h to be 1 over x plus h minus f of x, which is just 1 over x. We'll divide that by h. So now we have sort of a rationalization problem where we have to add the two top fractions. So let's go ahead and do that. So we have the limit as h approaches 0 of x over x times x plus h minus x plus h over x times x plus h. Then the minus sign will be distributed into here, so we'll put parentheses around there. Then h on the bottom, or the denominator. So then we'll do the limit as h approaches 0. So then these two will cancel out because of the distribution inward, and then we'll have a negative h on the top, and x times x plus h divided by h. In the h, since it's h over 1, we'll flip it. We can just put the h on the bottom, and these two h's will cancel out. So we're given the limit as h approaches 0 of negative 1 over x times x plus h. And if we plug in the 0 for the h, we get negative 1 over x squared, and that will be our answer. So today we learned what is a derivative and how do we apply it to its definition. I hope this helped, and thanks for watching.